Spring.
Bees will buzz, kids will blow dandelion fuzz, and I'll
Summer.
be doing whatever snow does in summer.
Arendelles in deep, deep, deep,
Autumn.
deep snow.
And winter.
You kind of set off an eternal...
The seasons are very common, but have you ever wondered why we have them? As the Earth spins on its axis, producing night and day, it also moves about the Sun in an elliptical orbit that requires about 365 days to complete. The Earth's spin axis is tilted with respect to its orbital plane. This is what causes the seasons. When Earth is in this position, sunlight shines equally on two hemispheres. You can see in the diagram that the North Pole is at the border between light and dark. The September equinox marks the beginning of autumn in the northern hemisphere and of spring in the southern hemisphere.
December solstice. 3 months later, Earth has traveled a quarter of the way around the sun, but its axis still points in the same direction into space. The North Pole seems to lean away from the direction of the sun. The solstice occurs when the pole leans as far away from the sun as it will during the year. You can see that the North Pole is in complete darkness. At the same time, the opposite is true in the southern hemisphere. The South Pole seems to lean towards the sun and is in sunlight. It is the southern hemisphere's summer solstice and the northern hemisphere's winter solstice.
This position is opposite the December solstice. Earth's axis still points in the same direction, but now the North Pole seems to lean towards the sun and is in sunlight. The June solstice marks the beginning of summer in the northern hemisphere. In contrast, it is the winter solstice in the southern hemisphere.
After another quarter of its orbit, Earth reaches another equinox. Half of each hemisphere is lit and the sunlight is centered on the equator. You can see that the poles are again at the border between day and night. Just as gravity causes objects near Earth to be pulled towards Earth's center, it also causes Earth and other objects near the sun to be pulled towards the sun's center. Fortunately, Earth does not move straight into the sun. Earth moves sideways at nearly a right angle to the sun's direction. Without the sun's gravitational pull, Earth would keep moving in a straight line into deep space. However, the sun's pull changes Earth's path from a straight line into a round orbit around 300 million kilometers across.
Just as a day is the time it takes Earth to rotate once on its axis, a year is the time it takes Earth to orbit the sun once. In astronomy, a revolution is the motion of one object around another. The word revolution can also mean the time it takes an object to go around once.